Welcome to example number 2. We have a conducting bar with a rod that is also conducting, and the rod is being pulled to the right with a force, and there's an opposing magnetic force backwards. And as it moves this way, there is a induced current in this circuit, and we're asked to find a number of things like EMF, the size of that induced current, the force that you would pull to the right on the rod, and what is the mechanical power needed to keep the rod at constant speed. So let's start off by solving part A. This, hopefully you will recognize, is a motional EMF problem. To calculate the EMF in such a situation, you would use the following equation, BLV. The magnetic field B is given in this problem. I believe it's 0.6 teslas. We have the length of the bar, L, and that is given as 0.1 meters. And we're given the velocity, which is 2.5 meters per second. And so go ahead and calculate that now. So this will give you a voltage between A and B, which is the motional EMF, of 0.15 volts. Okay, now moving on to part B, the induced current. Remember Ohm's law? V equals IR, so therefore the current is equal to the voltage divided by the resistance. This voltage is what we call the motional EMF, so it's the EMF divided by the resistance. The EMF we just determined is 0.15 volts, and the resistance of this loop is given as 0.03 ohms. So go ahead and put that in your calculator, and you get an induced current in that circuit of 5 amps. Okay, now moving on to part C, what is the force that is required as you pull it to the right? And hence it's equal to the magnetic force. So there's a couple ways of solving this. You have a force that you are pulling externally to the right, and then there is an opposing kind of magnetic drag, which we call FV. So the sum of those forces is equal to 0 because it's moving at constant velocity. So the external force that you would apply to pull it to the right would be equal to the magnetic force. So if you can find the magnetic force that's acting on a charged particle, then you could find out the force that you're applying. Well, actually, we would be applying a force across this whole wire. So what I would say is find the magnetic force on the entire wire. And hopefully you recall the magnetic force is equal to I times L times B times the sine of the angle between the direction of the current and the field that is going into the screen. That's a 90-degree angle, and sine of 90 degrees is 1. So substituting in, we have a current of 5 amps. We have the length of the bar given as 0.1 meters. And the strength of the magnetic field as 0.6 teslas. And this gives you an answer of 0.3 newtons that you would have to apply. And lastly, let's calculate the mechanical power. Recall the power is equal to the rate of doing work. So work divided by that time interval. Now, you're not really given the work, but we also know that work is force times the displacement times the cosine of the angle between the force and displacement, which is 0 degrees, all over that time interval. And displacement over time is really just velocity. So we have force times velocity, and we've written it this way because we know the force, it's 0.3 newtons, and we also know how fast it's going 2.5 meters per second. So really, to calculate that mechanical power, all we need to do is take that force that we just calculated at 0.3 newtons and multiply by that speed of 2.5 meters per second. So the rate at which the energy is being used is 0.75 joules per second, or you could say 0.75 watts. And that's it for this example.